So after we've discussed about the sub-base course. So after the sub-base, you have to design the base course. The base course is also your a granular course. Now sometimes you have to make some bituminous mix with that granular course to make it more stronger. Now the recommended minimum thickness of the granular base is 225 millimeter for traffic up to 2 MSA and 250 millimeter for traffic exceeding 2 MSA. As in the previous case, that for the subbase layer also there are different severe values and according to different thickness values. Similarly, for the base course also your minimum thickness is 225 mm for the traffic up to 2 MSA and 250 mm for the traffic exceeding 2 MSA. For heavily trafficked roads, use of water-bound macadam base laid by paver finishers or motor grader is recommended. So basically, you can ignore that point. So basically, for the heavy traffic roads, you can use some opposite materials like your granular aggregates plus bitumen content, and you can make some water macadam and use this for the heavy traffic loads where your traffic would be very much high. Where WMM construction should be adopted, that is water-bound macadam construction should be adopted in the base course for roads carrying traffic more than 10 MSA. The thickness of water-bound macadam shall be increased from 250 mm to 300 mm. So for the heavy traffic, if you are using water-bound macadam, in that case your thickness should be increased from 250 mm to 300 mm. So this is the base course. Now next is bituminous surface course. Now in the bituminous surface course, you know bituminous material will be used along with the other type of finer courses and small aggregates. Now it shall consist of either a wiring course or a binder course with a wiring course depending upon the traffic to be carried. So your bituminous surface course is generally consist of two layers. One is wiring course, which will be top layer, and another one is binder course. Now the selection criteria for the grade of bitumen to be used for bituminous course are given in the table. So these are the table, and because of different climate condition, as we have already discussed, based on the climate condition, different grade of bitumens are used. So these are the different grade of bitumen, and based on the climate condition, this type of grading use used. Where the wiring course adopted is premix carpet of thickness of up to 25 millimeter. The thickness of surfacing should not be counted towards the total thickness of the pavement. So whatever surfacing is there, that surface portion is not a structural portion. So for this reason, that the top wiring course or top surfacing course should not be considered as a total thickness of the pavement layer. So is this portion clear to you? Is this portion clear to you? Now we'll discuss about the failure of the flexible pavement. So after we complete the class, that is our one or two classes required. After that, we will directly go for the flexible pavement design using different code books. So there are different type of flexible pavement failures which we have already discussed. Now a highway pavement is a structure consisting of superimposed layers of processed materials above the natural subgrade. You know about this, above the natural subgrade we build different layers consisting of different type of materials and whose primary function is to distribute the applied vehicle loads in the beneath layer. Now, the pavement structure should be able to provide a surface of acceptable riding quality. All of you know about all these things, which would be of adequate skid resisting and which is favorable light reactive characteristics. Otherwise, it would create some glare that also we have already discussed and low noise pollution. Now, the major flexible pavements failures are generally fatigue cracking, rutting, and thermal cracking. So, these are the different type of crackings. Now, that thermal cracking can be avoided by using a suitable grade of bituminous material. Now, you know the fatigue cracking of the flexible pavement is due to the horizontal tensile strain at the bottom of the asphaltic concrete. Further, the failure criteria relates allowable number of load duplication to tensile strain, and this relation can be determined in the laboratory fatigue test as we have discussed our first equation, that is total number of allowable repetition is associated with the your modulus and your tensile strain at the bottom of the asphaltic layer, and rutting occurs only on the flexible pavement as indicated by the permanent deformation. So rutting is your permanent deformations, and when that rutting failure occurs when your rut depth is more than 20 mm, and for the fatigue failure when your total fatigue taking is more than 20% above the surface, in that case that pavement is considered as failed due to the fatigue failure. So this is the wheel load and your load distribution is assumed like that. Okay, that is your load is distributed with a larger area in a larger area. Okay, so in this way the wheel load is distributed over a particular area. Therefore, the intensity of the load will be reduced as the thickness of the pavement increases. Now there are different type of failures and these failures may be due to the subgrade, that is and how subgrade is failed or why subgrade is failed, due to the inadequate stability of the subgrade, excessive application of the stress, and plastic deformation. So basically there are two types of deformation. One is elastic deformation. Elastic deformation is that type of deformation which can be revert back. So after applications of the load, some deformation will be there, but when you remove the loading condition, in that case that would be going to its original positions. That is your elastic deformation. And plastic deformation is that type of deformation where the deformation is permanent. After the removal of the load also that deformation exists over the surface. That type of deformation is called plastic deformation. So generally plastic deformation occurs due to the excessive loading condition and sometimes due to the penetrations of the water in the subgrade layer. So therefore you have to always make your flexible pavement in such a way so that no drainage there is good drainage condition so that no water can be penetrated in the subgrade layer. And whenever there is some water logging area, in that case you can build some culvert or other type of structure so that that water cannot penetrate through the pavement layers. Otherwise, your subgrade will fail and that will cause some permanent deformation. Then failures in subbase or base course due to inadequate stability. Suppose your aggregate used in the base course or subbase course are not graded properly. In that case, because of the inadequate stability, it could fail. Loss of binding action. So if you are using too much rounded aggregates or flaky aggregate or elongated aggregate, in that case there will be no bonding between the aggregate particles and therefore that base or subbase could fail. Loss of bearing course materials and inadequate wearing course. So suppose your thickness of the base course and subbase course is lower, and suppose because of the excessive wiring and clearing, all the aggregates placed beneath the surface course have crushed. In that case, also failure of the surface or base happens. The causes of premature failures. Premature failures means suppose you have designed your flexible pavement for a 15 years lifelong, but after 5 years or 10 years it failed. So what could be the reason? So this is rutting due to high variation in ambient temperature. If the temperature variation, basically temperature variation has a little impact on the flexible pavement, but if the temperature variation is very much high, in that case it could cause a rutting failure. Uncontrolled heavy axle loads. If a particular vehicle is carrying more loads which is beyond its acceptable limit. In that case, the pressure exceeds over the road surface would be higher. That is, the stress would be higher. In that case, it would fail. And because of this, to control the heavy axle load, okay, because of this, the weight of the trucks or which carry goods are generally taken up in the straight border to know what is the load condition, whether they are overloading or not. So if they are overloaded, in that case it will create enough stresses over the road surface which will cause a permanent damage over the road. Limitation of the pavement design procedure to meet with the local environmental conditions. So to meet with the local environmental conditions and to acquire different type of materials, sometimes you have to deviate from the actual design parameters and you have to consider other things about the local conditions and other things. In that case also, because of the lack of materials and lack of design procedures, your pavement may fail. So there are different type of common flexible pavement or distress, and these are cracking, deformation, deterioration, mat problems and problem associated with the seal coat. Seal coat is placed over the top surface to seal any pores over the surface course. So cracking, this cracking may be of longitudinal cracking, it may be fatigue cracking, it may be transverse cracking, it may be reflective cracking, or block type or each. Okay, these are the different type of cracking. Then deformation may be permanent deformation or rutting. It may be corrugation. Corrugation means the pavement surface would be like that. That is called corrugation. Shoving, some portion may cut out like that. Shoving, then depression, that would be also like a rut depth. Okay, that is called depression. Then overlay bumps like that. So whenever the depression is there, adjacent to depression, some overlay jump would be there. Okay, so these are the different type of deformation. Then deterioration. So there are different type of deterioration like potholes, patching, revealing strips. Okay, polished aggregate, bumping, etc. are the deterioration. Then mat problem, that is segregation, checking, bleeding, and seal coats, there is rock loss, segregation, bleeding, fat spot, delimitation. So these are the different terms. So longitudinal cracking, if we discuss about the longitudinal cracking, there are different type of longitudinal cracking. So cracks that are approximately parallel to the pavement center line and are not in the wheel path. Longitudinal cracks are non-load associated cracks. So this type of long cracking are not associated with the loading condition. Location within the lane is significant. Longitudinal cracks in the wheel path are normally rated as alligator cracking. This is related as alligator cracking. See, this is the longitudinal cracking, which is parallel with the central line of the road, and it is not within the wheel path. Okay, this is your longitudinal cracking. Then fatigue cracking. Cracks in asphalt layers that are caused by repeated traffic loading. So for the longitudinal cracking, that is not associated with the loading condition, but for the fatigue cracking, that is associated with the loading condition. So the crack indicate fatigue failure to the asphalt layer. So when cracking is characterized by interconnected cracks, the cracking pattern resembles that of a alligator skin or chicken wire. Therefore, it is also referred as alligator cracking. So this type of cracking, see, one crack is associated with the another cracking condition. Okay, and this type of cracking is generated over the wheel path, and that is associated with the tensile strain at the bottom of the asphaltic layer. Okay, so all these cracks are interconnected cracks, and this cracking pattern resembles alligator skin, therefore it is called alligator cracking. Now, transverse cracking is that type of cracking which occurs at the transverse direction. See this type of cracking. Then reflection cracking, cracks in hot mix asphalt overlay surface that occur over joints in concrete or over cracks in HME pavements. So see, these are the reflection cracking. Why reflection cracking? See these two cracking, see these two cracks, this crack and that one. It is similar, that is, it is resemble like a reflection of this cracking is that one, or reflection of the cracking is that one. So therefore it is called reflection cracking. Then block cracking. So here the cracking would be in a pattern like of box, okay, or block. So therefore it is called block cracking. Then each cracking, that is the each portion of the pavement would be get deteriorated, that is called each cracking. So it is located within 2 feet of the pavement edge, adjacent to the unpaved shoulder, includes longitudinal cracks outside of the wheel path and within the 2 feet of the pavement edge. So generally this edge cracking would be within the 2 feet from the edge of the pavement. Then rutting is permanent deformation. Longitudinal surface depression that develops in the wheel path of flexible pavement under traffic. It may have associated transverse displacement. So see, this type of pavement deformation is caused because of the rutting failure, and this would be along the wheel path. So see here, this load application would be placed here, load application would be there, and because of the load application, some compressive strain would be generated at the top of the subgrade layer, and because of this depression occurs, and therefore this rutting failure occurs. Now corrugation, so rutting is in the longitudinal direction and corrugation is in the transverse direction, and it would be like that corrugation, like your corrugated iron sheet. Then showing a longitudinal displacement of localized area of the pavement surface. It is generally caused by braking or accelerating vehicles and is usually located on hills or curves or at intersection. It also may have vertical displacement. So see, these portions of the road got displaced. Okay, and this type of failure may occur due to the excessive speed or braking conditions or accelerating vehicles and usually located on hills or curves. Then depression. So depression is small localized surface settlement. So it would be cost for a smaller area, cost over a smaller area. That is your depression. So this is all about today's class. You can leave the meeting.